Good morning, everyone. It's so great to see you all here in the live chat. For today's class, what we are going to attempt to do, we'll see what happens. I don't really know if we're going to be able to, but we'll try. Good morning, Kevin. Is we should try to finish these Unit 3 notes today. So that's the goal. Let's see what happens. As a reminder from last class, we were looking at strategies for solving word problems. We focused on the idea that we need to establish a relationship first. Once you have the relationship established first, that kind of relates the, more than one unknown to each other, you then write down the equation. Good morning, Alexis. You then write down the equation, you solve it, and then you answer the question being asked. So that last piece is super, super critical in addition to establishing that relationship up front. Ciasia, good morning, no worries, okay? So keeping that in mind, we're going to move to numbers 23 and 24. Now with 23 and 24, there's actually only one unknown, so we just want to use a variable, identify what that variable means, and then work through the equation and solving. So these two are going to go actually pretty quickly. So let's take a look, and then we'll see some maybe geometric problems. All right, check it out. The cost of a VR headset, including 6% sales tax, was $284.61. What was the price of the VR headset before tax? So right away, I noticed that there's only one piece of information that we're actually missing, and that's the price of the VR headset before tax. We can use any variable we want, P, VH, whatever we would like. I'm going to call P the price of the headset before tax. Oftentimes, it's helpful to write down all of that information in terms of how you label it, just because it's easier to see what's happening. Now, I want us to focus on word-for-word interpretation. So, we know that P stands for the price of the headset before tax. So, check this out. The cost of a VR headset, which, by the way, implies as is before tax. So, I'll write that in a second. But then it says, including a 6% sales tax. So, check this out. The cost of the VR headset, including, we know that when we have tax on an item, we have to add it to the cost, so we have to pay for that as well. So plus, and we want 6% sales tax. As a reminder from our conversation last week, we have to attach the percentage to the variable itself. Good morning, Liam, welcome. So we have 6%, which is 0.06, but without the P that says 6 pennies. That's not the case. I wish, but it's not the case. So the cost of the VR headset plus 6% of the VR headset, you heard that? The cost of the VR headset plus 6% of the cost of the VR headset was stands for equals $284.61. I hope this makes sense, especially after our conversation about the winter boots. From last class, we calculated the cost of the winter boots with 8% tax. You all did that, no problem. The tricky thing is understanding that you need that variable next to the next to the 0.06, so that way you can imply there's a percentage of the item, okay? Here, we have P plus 0.06P. Perfect. These are like terms, so we're going to combine them. If this seems weird to you, again, you can write a 1 in front of that P since that's its coefficient. 1P plus 0.06P is 1.06P. Combine those two is equal to 284.61. At this point, all we have to do is divide by 1.06 on both sides. So essentially, notice here that the 1.06 divided by 1.06 is simply P, or 1P. So we take 284.61 divided by 1.06, and we should have $268, and it says 0.5. You know what that means. 0.5, think money. You need two values after the decimal. So to the hundredths place, we have a 0, right? So $268.50. That is the cost of the VR headset before tax. So the VR headset was $268.50 before tax. And we've answered the question being asked. It's really important. Just like we had in our previous problems, we identified Lucky Charms equals, Fruit Loops equals, and we gave the unit 120 calories, 110 calories. In this case, because we only have one value, it's nice to throw in a statement that explains what it is that you just found. So take 60 seconds to answer number 24. Keep in mind it's the same idea. It's the same idea, but it's not cookie cutter, okay? So I'm going to read this to you. To attract new customers, LA Fitness decreased its annual membership fee by 15%. If the annual membership fee is now $119, what was it before the decrease? 60 seconds starting now. Okay, so after looking at some of the responses in the chat, let's dissect this together. So we know that the annual membership fee is now $119, and that's because they decreased its annual membership fee. So we want to know what the annual membership fee for LA Fitness was before the decrease. So what we may want to say is we'll call A, the annual fee before the decrease. And Claire, great question. So what we're going to do is we're actually going to do essentially a word-for-word interpretation, but we really have to think about the statement being written here. So to attract new customers, LA Fitness decreased its annual membership fee. So we had the annual membership fee, right? And then we decreased it by 15%. So we decrease, which is subtraction, by 15%. Remember, it's 15% of the annual membership. We don't know what it was before. So what the annual membership fee was before the decrease, and let's take away 15% of that, and then we'll say, okay, and then it becomes $119. Hopefully that's clear. Now, similarly to number 23, we had 1p plus 0.06p, so we combine like terms by adding our coefficients, right, because it's addition. In this case, we have 1a minus 0.15a. Think of this as $1, take away 15 cents. If you have $1 and you give away 15 cents, well, you're left with 85 cents. So then you have 0.85a is equal to 119. Take both sides, divide by 0.85 so that you can isolate your variable a. And then when you do the math, you get $140. So Doc, excellent work here. Notice that no matter what, because we know that the annual membership fee was originally greater than the 119, we should be looking for a result that is greater than 119. If we're not getting a result that's greater, then we have to tweak our equation. We have to figure out what went wrong and where. So one of the things I really want to emphasize to everyone is take a couple minutes to be super critical of what it is that you're doing. Think about what the values could be. Think about something that's reasonable. And then say, all right, is my answer in line with what's reasonable for this problem? Because if it's not, then that's a huge indication to you that you should say, whoa, let me look back at the equation, see what happened. Maybe I missed a decimal, maybe I missed a coefficient, right? Like think about all of those things as you progress through the problem, okay? So even when you finish the problem, double check to make sure that it actually looks and sounds right, okay? So at this point, let's write our statement. The annual fee was $140 before the decrease. The great thing about this is that we know that our value is greater, so we can make a note. Oh yeah, that's what it was before the decrease. Excellent. Right, Kayla, and that's okay. So we have to be careful with the equation here. Because it was a decrease, we're actually subtracting that excess amount. Another way to think about this is originally you're responsible for 100% of the annual fee, right? But then LA Fitness says, let's take off 15% of that. Well, if you take off 15% of that, you're now only responsible for 85%. Does that make sense? So it should have been 0.85A because you're saying I'm no longer responsible for 100% of it. I only have to pay for 85% of it. Okay? Hopefully that thought process helps as you work through these problems. Let's turn the page and keep looking at some more. So we have page 8. Now we're getting back into the relationship, right? So on our previous page, we had only one unknown. On this page, we're going to have two unknowns yet again. So let's look at 25. Lilia rollerbladed 4 miles less than twice the distance she ran. The total distance she traveled was 15 miles. How many miles did she rollerblade and how many miles did she run? Hopefully, just by looking at this question, we recognize that our two unknowns are how far she rollerbladed and how far she ran. So we're going to set up our relationship just like we have before. So I'm going to say rollerblade equals, and then run equals. So looking for that relationship, notice we're told that she rollerbladed 4 miles less than twice the distance she ran. So she rollerbladed 4 miles less than, ooh, this is fancy. Remember the less than, we have to reverse the order. So 4 miles less than twice the distance she ran. I'm going to use capital R to represent the distance she ran. And there's our relationship. So 4 miles less than twice the distance she ran. Here's the distance she ran. Just like before. We don't change this part of it. So we found the relationship. Next, you're told that the total, you know what total means? That means add. The total distance she traveled was 15 miles. So essentially, you're going to take however far she rollerbladed and however far she ran, and you're going to add those two and set it equal to 15. I apologize for not changing the tense. I just want to keep rollerblade plus run. So we know the distance she rollerbladed plus the distance she ran is a total of 15 miles. Well, the expression we called rollerblade was 2r minus 4. So I'm going to replace that here. Then we have a plus, and we have to add the run. So that's r is equal to 15. Notice how we make that direct substitution with our expressions. Next, we're going to combine like terms. 2r plus r is 3r. So we have 3r minus 4 is equal to 15. Let's add 4. So we have 3r is equal to 19. Now, the interesting part about this, and I would make a note, for instance, on like a test or a homework assignment, is that I'm okay with you giving me a decimal value for this particular problem. So when we divide by 3, we get r is equal to 6.3 repeating. We learned that 6.3 repeating is the same as 6 1/3. So if you want, you could write 6.3, which, by the way, is not perfect. Or you could say 6 1/3 miles, right? 6 1/3 is actually really, really nice. That's a perfect value, as opposed to 6.3, which has rounding error. 6 1/3 looks like that, which is very different from 6.3. So this is perfect. This is a perfect answer here, but I'm okay with either. Yeah, let's leave it at that. So next we want to determine how far she rollerbladed. So we could do this one of two ways. We can take our value, plug it into the relationship just like we have before. So I can draw an arrow and say we can plug this right into our relationship. Or we can say, well, I know the total distance was 15 miles. So if she ran 6 1/3, well, how much is left? So I'm going to show you both ways, okay? Thank you, Kayla. That's awesome. So I'm going to show you both ways. So we know that for rollerblade, that's equal to 2 times r minus 4. So we could do 2 times 6.3 minus 4. I know I'm using the decimal here. That's okay. I'm going to show you exactly how to work through this. Oh, thank you, Kayla. That's perfect. So we have 2 times 6.3, which is 12.6, minus 4, which is 8.6. Now, I'm going to write 8.6, but I want to show you how we can actually provide a perfect answer as well. So here I'm going to say 8.6 miles, which is a little bit off because, as you know, if you take 8.6 and you add 6.3, you actually have 14.9, so we're a little bit off. But if this were 8.6 repeating, then we would round to 8.7. Let me show you something. Let's say that I left it 19 thirds. So we have 19 thirds, which is 6.3 repeating. Let's multiply that by 2. So in this case, I could just draw a line here that shows I took the 6.3 repeating, I multiplied it by 2, and then I subtract 4. Take a look at your result. 8.6 repeating, which means we can say 8.7, or if we wanted to be exact, 0.6 repeating represents 2/3. Yes, Kevin, we can use mixed numbers in this case. So we could say 8 2/3 miles. Hopefully that actually makes sense, because if you take 8 2/3 and you add 6 1/3, that's going to give you 15 miles perfectly. So there's a bunch of ways you can go through this. Let's write down here that she ran. We can say 6.3 or 6 1/3 miles. I am okay with either of these. I just want you to see what your options are in this case. All right. Sorry, my cloud got all crazy over here. But always think about, getting as close to the correct answer as possible and as accurately as possible. Oftentimes that means leaving it in fraction form. If some of you are thinking, well, couldn't I have just left it as 19 thirds? Yes, you totally could have done that. If you had 19 thirds here, then this one would have been 26 thirds. Okay, and we can definitely find that out in many different ways. You could take 19 thirds from 15 and then find that you'll get 26 thirds. So it's totally up to you. Let me do a little side work to show that to you real fast. So a little bit of side work. Again, you don't have to do this, but why not? So if we know the total distance was 15 miles, and she ran 19 thirds miles. So we know that when we subtract fractions, we need to have a common denominator. So I'm going to multiply by 3. That gives us 45 thirds minus 19 thirds. And when we do 45 minus 19, we get 26 thirds. And if you didn't believe me, 26 thirds is, oops, I typed it in wrong. 26 thirds is 8.6 repeating. Da, 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 da. So it all comes full circle. There's so many different ways to obtain the answer, but I do want you to get as close to accurate as possible. So 6.3, 8.7, cool. 6 1/3, 8 2/3, even better, which means 19 thirds and 26 thirds is just as great. Okay? You won't see a ton of those. So don't overthink it. Don't sweat it too much. Let's look at 26. Charlie owns 300 more than twice the number of baseball cards that Finch owns. The difference between the number of cards that Charlie and Finch own is 420. I'm actually going to start off with a relationship. I want you to finish it. I want you to think about the equation and solve it. So we have two people. We have Charlie and we have Finch. Okay. What this statement is missing is how many cards did they each own? Good. Next time I edit these notes, I'll remember to add that question. So we are told that Charlie owns, okay, Charlie owns 300 more than twice the number of baseball cards that Finch owns. So twice the number of cards that Finch owns. So twice Finch, which means Finch is just F. Okay, remember, one of these has to be the variable by itself. One of these has to be the independent variable. Otherwise, how do you even establish that relationship? So I've started this problem for you. Go ahead, write your equation and solve it. When you have an answer, please type it into the chat. And don't be shy about it. It's okay if it's not correct. It's not like no points are being taken away. Nobody's getting hurt. This is awesome. It's just an educational experience. Maximize it. Okay, 60 seconds, 60 to 120 seconds. Let's see what you got. Awesome. Again, thank you all so much for being willing to share your work, to share your results, because that's what this is all about, right? We're growing together. We're getting better at this math together. I guarantee that from when we all started to where we are now, you've seen immense growth. I know it. I can tell in your work. It's a beautiful thing. So just stay focused on that positivity. Even if we make a mistake here or there, this is part of that growing process. Okay? So notice here the first sentence pertains to that relationship. So we took care of that. Then it says the difference between. I want you to consider what difference means. Difference means subtraction, right? So the difference between the number of cards that Charlie and Finch own. Subtraction in this case is order specific. So we want the difference between Charlie and Finch. Notice the difference is literally between Charlie and Finch, and that is 420. Sometimes it helps to simply write out the phrase. If you want to do that, go for it. If you don't, that's okay too. But I'm going to write it out just so you all can see that. We know that Charlie is 300 plus 2F. So I'm going to replace Charlie with his expression. Then we have minus, and we know Finch is just F. So I'm going to bring that down. Next, notice we have 300 plus 2F minus F is equal to 420. Here are my like terms. 2F minus F is F. Right? Think of it as 2F minus 1F is just 1F. And I'll write 1F. Who cares? That's fine. And then notice here 300 and 420 are like terms. So I want to bring the 300 over. So I'm going to subtract 300 from both sides. These cancel. 0 plus 1F is just F. And then 420 minus 300 is 120. So we found that F is equal to 120. Right. And Doc, that's okay. That's part of this whole process. If it said the sum of the number of cards that Charlie and Finch own is 420, that would have been addition. So because it said the difference between Charlie and Finch, that indicates that we're subtracting. And I love the fact that you're sharing that perspective. So thank you so much. At this point, let's go ahead and substitute back into the relationship. We're going to continue doing this process so that it becomes second nature to all of you. We know that Charlie is equal to 300 plus 2 times F. F is 120. So we have 300 plus 240, which means Charlie owns 540 baseball cards. So that's Charlie. We also know that Finch is F by itself, and F is 120, so we could say that Finch owns 120 baseball cards. And that concludes the problem. So if you said that Charlie owned 540 and Finch owned 120, excellent work. If you were off just by a little bit because of your addition sign, but everything else looked great, you would get partial credit, right? These are really awesome things to think about, but we want to tighten it up. So be super careful with this dissecting the word problem and interpreting those operations. All right? Excellent work. This is fantastic. And thank you to all of you who gave this a shot and shared in the chat. That means a great deal. Let's take a look at number 27. We're now ready to look at some geometric problems. The really cool thing about this is if you see a shape, draw it, right? If it's a rectangle, draw it. Triangle, draw it. Circle, draw it. Whatever that shape is, if you know it's a geometric problem, draw it. It's going to help you out. I don't know about you, but I'm a super visual learner. Like I need to see the diagrams. I need to be hands-on. Like the visuals really, really help me. I visualize almost every day. So when I'm learning something new, to have the visuals, it helps me. So I'm hopeful that this is going to help a lot of you as well. Try it out, see how it works. If the visual is exactly what you need, then keep at this, okay? Keep applying this concept of, in establishing the relationship, we draw the diagram. Let me show you what that looks like. A rectangular sign has a perimeter of 12 feet. So right off the bat, I see that we have a rectangle. So I'm going to draw that as best I can. And it has a perimeter of 12 feet. As a reminder, the perimeter is the sum of all sides. So that's something I want to think about. If I add all these sides, it's going to be 12 feet. Then it says, find the dimensions. That means find the length, find the width. If the length is 1.5 feet less than twice the width. So I'm going to underline this. Okay, so the length and the width are the two pieces that we're looking for, right? We know that the length is 1.5 feet less than, let's put some stars here, less than twice the width. So 1.5 feet less than twice the width. And notice we use W for width. If you say width, you know it starts with a W. And that implies our width is also W, right? We don't know what it is. So here's our relationship. Now, I have this naked rectangle. I want to label all the sides. What I would recommend, not that it matters, but I would recommend that your longer sides be your length, longer length, and your shorter sides be your width. So the length is 2W minus 1.5. So I'm going to dress my rectangle. 2W minus 1.5, 2W minus 1.5. Notice the other sides are bare, so we're going to dress that as well. The width is just W. So let's label it. Now that I have my rectangle completely labeled, by the way, this is a fantastic strategy. This will help you to get these questions correct every single time. Obviously, within reason. Your relationship needs to be perfect, but having a visual really, really, really does help, I promise. But now that it's completely dressed, we could say, okay, the perimeter is 12 feet, and the perimeter is the sum of all the sides. So I could use your perimeter formula for the rectangle, or I could just do this. 2W minus 1.5 plus W plus 2W minus 1.5 plus W is equal to the perimeter, which is 12 feet. We could use our formula by saying 2 times 2W minus 1.5 plus 2 times W is equal to 12. But it's the same thing. It's the same exact thing. So that depends on your style. You know, you get to choose your flavor, right? So if you want to write it using your perimeter formula, which is 2L plus 2W, in this case that'll work because we have all four sides and we're taking into account all four sides. Feel free to use that. Otherwise, just write it all out and then combine like terms. So 2W plus W is 3W, plus another 2 is 5, plus another 1 is 6. So we have 6W. Then I have a negative 1.5 and another negative 1.5, which gives me negative 3. And that's equal to 12. So we're going to go through the motions, continue solving. I'm going to add 3. That gives us 6w plus 0, which is just 6w, is equal to 12 plus 3, which is 15. I'm going to divide both sides by 6, and I get 15 divided by 6, which is 2.5. As always, take your unknown and plug it right back into the relationship here. And we note that length is 2 times w. W is 2.5 minus 1.5. 2.5 is 2 times 2.5. This is going to give us 5. 5 minus 1.5 is 3.5. So notice here we're talking about the length. We notice the units are in feet. So the length is 3.5 feet. And the width, which is just w, is going to be 2.5 feet. And that answers the question being asked. Okay, keep in mind, we didn't actually have to find the area, but sometimes you could take it a step further. I could have said, you know, find the dimensions if the length is 1.5 feet less than twice the width, and then I could have followed that up with, okay, what's the area? So as a little side quest, yes, I'm literally going to call it a side quest because I'm a nerd and that's what I do. So the side quest is let's also find the area. The area for a rectangle is length times width. So if I want to calculate the area of this rectangle, I'm going to take the length, which is 3.5, and I'm going to multiply it by the width, which is 2.5. And that's going to give me an area of 8.75 feet squared. It's feet squared because think of it this way. 3.5 feet times 2.5 feet, feet times feet, feet squared. Okay, so I want to just put this on the side here. It's like a little side quest. You never know if that's something you're going to be asked to find. So we might as well just take it one step further so that we're used to that kind of idea. All right, let's take a look at another geometric problem. I hope you're enjoying these. I love the geometric problems because you get to draw them, right? If there's a visual, go ahead and draw it, and then we'll proceed through the problem like that. Number 28. Each of the 2 equal angles of an isosceles triangle. Ooh, do you remember what an isosceles triangle is? If you don't remember, that is okay. That's what I'm here for. So an isosceles triangle has 2 sides that are the same. Oh, man, my triangle is not that great today. These legs are the same, and the cool thing is they point to the angles that are equal. So these 2 angles are equivalent to each other, with this one being something totally different. Okay, so the 2 sides of an isosceles triangle that are equal, they point to the angles that are also equal. Kind of neat, right? Okay, so each of the 2 equal angles, so we're talking this angle and this angle, right? Each of these is 12 less than twice the third. Okay, so each one of these is 12 less than twice the third angle, and let's call it A. So each of these are 12 less than twice the third, which means my third angle is just A. I don't know it. Consider we're not talking about the sides here, we're talking about the angles. Then it says, find the angles of the triangle and round to the nearest tenth if necessary. So there's a piece of information here that's missing that we actually have to just know, and it's the property of triangles. So when you think about triangles and their angles, one of the pieces of information, or one of the properties, is that the sum of all 3 angles of a triangle is 180 degrees. That's a property that you need to keep in mind. The sum of all three angles of a triangle is 180 degrees. Having said that, let's use the same process that we used for our previous problem where we simply just added up all the sides. This time we're just going to add up all the angles. So we have A plus 2A minus 12 plus 2A minus 12 is equal to the sum of all three angles, which is 180. Not bad, right? It becomes easier. Yes, Doc, perfect. It becomes easier to digest when you have that visual that you can build off of. I love it. I hope you do too. I find it to be incredibly helpful. So we have A plus 2A plus another 2A, so that's 5A. Negative 12 and another negative 12 is a negative 24 is equal to 180. Let's just solve this. We'll go through the motions, add 24 to both sides. 5A plus 0 is 5A, so 5A is equal to, and this gives us 204. We're going to divide by 5. So we have 204 divided by 5 gives us 40.8. So A is 40.8. Now at this point, we're going to look at the relationship here, which is in our triangle. So notice that the third angle, which is just A, is 40.8. We know that that technically is our third angle. So I'm going to write first angle, second angle, third angle. The third angle is just A, which is 40.8 degrees. So that takes care of that. Notice that my equal angles are both twice A minus 12. So 2 times 40.8 minus 12. So let's do the math. 2 times 40.8 minus 12 gives us 69.6 degrees. And we know that the second angle is exactly the same. Okay, and there you have your answer. First and second angles are both 69.6 degrees, and the third angle is 40.8 degrees. Excellent, excellent, excellent. What I'd like you all to do is take the next 4 problems home with you, and I want you to complete them for homework and bring them to class tomorrow. So what we will actually be doing is for tomorrow's class, we are all going to meet in Zoom. All right, no YouTube live stream tomorrow because we just finished Unit 3, which means we're ready for the next test. Okay, so I'm going to read to you each of these problems in case you don't have your notes or in case you're a guest and you want to try out these problems. But tomorrow in Zoom, we're going to go over these together. Okay, let's take a look at the questions. A rectangular garden has a perimeter that measures 126 feet. If the length is 19 feet greater than the width, what are the dimensions? Number 30. Angles A and B are complementary angles. Angle A is 15 degrees more than 3 times the measure of angle B. What is the measure of each angle? Number 31. Angles C and D are supplementary angles. Angle D is 25 degrees more than half the measure of angle C. What is the measure of each angle? And 32. One angle of a triangle is 8 degrees greater than the smallest angle. The third angle is 4 degrees greater than twice the smallest angle. Find the measure of the 3 angles of the triangle. If the toughest part tends to be the setup, then take a few extra minutes to think about what it's saying. Is there a geometric figure that we can draw and label? Right? Is there a statement that tells me the relationship between the two? Is there a different statement that implies the equation? So it's going through the motions to carefully dissect this, okay? Not all of them are about triangles. So for instance, number 29, we're dealing with a rectangle. Numbers 30 and 31, we just have relationships. We actually don't have a visual that we need to apply to numbers 30 and 31. Notice for number 30, you're just told that they're complementary angles. What does that mean? For number 31, you're told that they're supplementary angles. What does that mean? Again, for those two, there won't be any visuals for that. For 32, we're explicitly referring to a triangle, so draw the triangle. So 29 is a rectangle, 32 is the triangle. The other two, just establish the relationship. Angle A equals, angle B equals. For 31, angle C equals, angle D equals. Hopefully that's enough to get you on the right path. All right, I will see you all tomorrow. Excellent work today. Bye.